All right, everybody. This is the 6.2 video notes. And this one's I'm gonna skip a lot of things just because the best way to learn about transforming random variables. So we're gonna talk about, okay, well, we have this random variable, but maybe it's in some weird scale that we don't want. So we're gonna change it. Maybe like in this first example, we're gonna look at like cost per credit hour for colleges. So here we're looking at the cost per credit is only $50. So then, okay, well, here we're taking the number of credits. So we're going to multiply everything by 50 to see how much we're going to pay in terms of tuition, right? So there's loads of things that we can do to transform variables. Common ones. Transforming from Celsius to Fahrenheit. Going from metrics to American units. All those kind of things that we do to transform random variables, and what's going to happen to each one of those distributions. So what happens when we multiply by 50? What happens when we add or subtract? What happens when, and so on and so forth. And so the best way to do this is going to be to actually go in and calculate a lot of these things. So I'm going to skip a lot of pieces, but we'll talk about those in class, so don't worry about that. But I do want to obviously talk about a couple things. So I'm going to stop sharing my screen for 1 second while I pull up a camera or a calculator. And so the first thing that I want you to do is calculate the mean and standard deviation of the first table there, right? And so just as a reminder, right, when you're calculating discrete, this is a discrete case, right? We only have you can't have 12.5 credits, right? So 12, 13, 14, etc. And so you take each one of those x's multiplied by the probability and add them all up, right? And so here we only have 2, 4, 6, 7. 7 possible outcomes. So that's not too bad. You could do it by hand. It wouldn't take you that long. But think about if you were to have, 50 or 60 possible outcomes, right? Then all of a sudden this becomes quite tedious to calculate all these, to calculate the mean. And then standard deviation becomes even worse, right? So just as a reminder to calculate the standard deviation, you're going to take the expected value that you calculate, the mean, okay? So you're going to take the x value, subtract away the mean, and then multiply that and then square it and then multiply that by the probability and then add those all up, and then that's going to be your variance, right? And then you can square root that to get standard deviation at the end. And so while this calculator is pulling up here, we'll kind of go through. I'm going to show you how to do this on the calculator to save yourself a little bit of time. And again, as a reminder from the last video, if you're going to use a calculator, that's fine. But remember that when you use the calculator, you got to show the first couple of terms. So that's always the kind of caveat. You got to kind of start it off and then go from there. So if I'm on the calculator, okay, you can go to list and spreadsheets. And then here I'm going to label my list X and P. Okay. And so I'm just going to type in the data 12, 13, 14, 15, 16, 17, 18. And then type in the probabilities. And again, you should probably check to make sure this is the legitimate probability distribution function to make sure they all add up to 1. They do, but you should definitely check on the AP test because it's going to be something that they're going to try to sneak in, especially in the multiple choice section, to see if you're even paying attention. Okay, so I've typed in my data. And now we can go to one variable stats. And number of lists is still 1. Okay. Now the thing you're going to change, so my X list is still my X's. The frequency list is the thing you're going to change. So I talked about this in the last video, but here's kind of just a walkthrough of it. So now you change your frequency list to my probabilities, hit OK, and it's going to spit out all the data that I need. Okay. So here's my X bar, 14.65. Standard deviation, 2.056, and variance, you can square that number to find your variance. Okay. And then it'll also give you the quartiles, which is also pretty nice, but kind of just gives you a bunch of numbers there. So this is, just doing it on the calculator. And what I want you to do, right, is now, okay, so now I'm going to give you, we saw those numbers. 14, the mean was 14.65, the standard deviation was 2.06. Okay. And now I got this new table where I multiplied everything, all my x's by 50. Okay. Probabilities stay the same, right? So I'm just transforming my random variable being the number of credit hours I take. Okay. So I transformed it by multiplying everything by 50, which is this function right here. right? This new variable t, which stands for tuition, is equal to 50 times x, where x is the number of credits I take. And then you kind of have this table here, and you can calculate the mean and standard deviation. And I want you to do is just look at what happens to those numbers. Okay, what happens between the numbers that you get here and the numbers that you get down here. Okay? And I also want you here. We kind of said draw histogram. Draw histogram as well. See what happens to the shape. See what happens to the numbers, and see what you come up with. Okay. And then do the same thing again down here. But here now I'm adding by 100. So I'm taking my t values. So here I've taken this table. I'm going to add 100 to it, okay, as a one-time fee. And again, see what happens between the second one and the third one. Okay, so you just want to make these comparisons. It's going to be the best way for you kind of to see what happens when you add or subtract these values. So again, we'll kind of go through all of these things in a little more detail in terms of like what actually happens. So linear transformations. Well, let me back up again a bit. So yeah, we'll kind of go through all this, but I want you to do it first on your own, because once you just type everything into the calculator, see what happens. It's also good practice on the calculator. And then you should just be able to see exactly, you'll have some intuition about what's going on with all these data sets. And so when I look at this third data here, this is called a linear transformation, especially if you think about it when you compare it to A, right? So when I compare it to the very first table that we did, okay, I've multiplied everything by 50 and then added 100, right? So as an equation, you have 50x plus 100, right? So that's like y equals mx plus b or ax plus b. So that's the linear transformation. Again, we'll talk about that in more detail. But yeah, see if you can kind of do these first two pages. You might be able to do it on your own when you start typing everything in. It'll be kind of interesting to see. And so now we can also combine. So now we transform random variables. You can also combine random variables. And so what you can look at here in this problem, we're looking at the height difference between males and females of speed daters. So you have the mean of 68.5 and a standard deviation of 4. And the height for female is normal with mean 64 and standard deviation 3. And so what's the probability that a randomly selected male speed dater is taller than a randomly selected female? Okay, and so instead of, we kind of have this complicated problem because we have these two distributions, right? So we have males, and then females a little shorter, so they're going to be kind of like over here. Okay, so we have these two distributions, okay, and we want to find the probability that a male is taller than the female, right? So we want to kind of find this weird area where it's kind of like this kind of outside part right here. Okay, well, how do we do that? It's going to be kind of hard to do because you have this distribution that's kind of always changing. So instead of looking at these two separate distributions, what we can do is kind of simplify this down and just look at one distribution where I'm looking at the difference. And so I can say that my difference is equal to males minus females. Okay, so I can look at the difference between these two distributions. And so what you're going to do here is you can look at the mean difference, so mu d is going to equal to the mean of the males minus the mean of the females. And so that's going to be 69.5 minus 64, and that gives you 4.5. And what you're going to notice is, and then when you do the above calculations, is to know that you can subtract means, but the one thing you can't do is subtract variances. So what you can do is you're going to add the two variances. So variances always get added together. But if you think about it, that kind of makes sense because variance is a measure of spread of how far things are away. So if I take this distribution and I add a second distribution onto it, right? If I add a second distribution onto it, something like this, right? My spread just went from here to now here. Okay, and so my distribution is always going to get bigger as you go along. My spread's always going to get bigger as you go along. Okay, so your variances added together, you just take the variance of the males and the variance of the females and add them together. So you have, and you can only do this with variances. You can't do it with standard deviations either. So sigma squared m for the males plus sigma squared for the females. And so we know the standard deviation. We just need to find the variances. So it's going to be 4 squared plus 3 squared, which equals 25. But again, this is the variance. So if I want to find the standard deviation, I'm going to square root that answer, square root of 25, which is equal to 5. And so now we have the mean and the standard deviation of our new distribution, which is only looking at the difference between males and females. Okay. And so again, I want you to think about, well, what happens with, take a look at the means or the standard deviations. So what do you think is going to happen about the shape and the center of this difference? Okay. And then again, these last 2 problems we'll do together in class. I want you again to work on it first because it's going to be one of those things that it's a tougher concept for sure. But I want you to like mess around with the data in the first 2 pages of this. That'll hopefully give you some intuition. And then when we get to class, we can kind of look at these specific examples. And we're going to do a state plan to conclude with both of these in class. So that's kind of it for this video, guys. Again, it's kind of weird because I want you to mess around with it. But we'll kind of fill in some of the blanks as we go along. As always, if you have any questions, please let me know. But if not, have a great rest of your day.